Hello, this is the first in a two-part video on quadratic functions. This part will focus on graphing from the standard form and from our ax squared plus bx plus c type format, and the other one is more on applications. So let's go ahead and get started. First, start about a quadratic function. A quadratic function always gives a parabola, and our parabola, we have a vertex, so we have a high point or low point. So if it opens upward, it's going to be a low point. If it opens downward, it's going to be a high point, and that point is called our vertex. For all of these, we have an axis of symmetry that's a vertical line that goes through our vertices. So that axis of symmetry is always going to be x equals whatever the x coordinate of our vertices is. And once we have our vertex, we want to find some other points on our graph, and the easiest points to find are our x-intercepts and our y-intercepts. So when we're given an equation, we want to identify if it opens upwards or downwards. We want to find the vertex, and the vertex is always going to be the minimum if it opens upwards or the maximum if it opens downwards. We want to find the axis of symmetry, and again, that's just x equals the x coordinate of our vertex. We want to find the x-intercepts, so we set our function equal to 0 and we solve for x. We can find our y-intercepts by setting x equal to 0 and solving what the y is. And then we want to plot these points and draw a smooth curve. Okay, so there's two ways that we usually encounter equations for a quadratic function. And the first is a standard form. This is g of x is equal to a times x minus h squared plus k. So from this, it's very clear from what we've talked about earlier in the course about transformations that this is some sort of transformation of our x squared general parabola. So if a is greater than 0, this is going to be opening upwards, and if it's less than 0, it's going to be opening downwards. Our vertex, well, we've shifted our x squared to hk. So just from transformations, if we have x minus h squared, that means we shift it 2 to the right, we shift it to h, and then k is moving it up or down. So this is our vertex, is our hk, when we have it in this standard format. Our axis of symmetry, again, is the vertical line that's going through the x coordinate of our vertex. So the x coordinate of our vertex is h, so the axis of symmetry is x equals h. So let's go ahead and take a look at it. We have this, f of x is equal to negative x minus 1 squared plus 4. So we want to look at this. The first thing that we want to look at is we want to know what this a is. Well, this a is equal to negative 1. So this is going to open downward. Downward. So we're going to have a parabola that looks like this. Okay, so that's helpful. So when we find the vertex is going to be our maximum point. So we have a vertex of hk. Well, this is x minus h. Well, h is 1. So that's, 1. And plus k. K is 4. So we have a vertex at 1, 4. And I'm just going to plot this over here already. Here's our vertex at 1, 4. Okay. Now, the next thing that we want to do is we want to find some points on this parabola. So the easiest things to do is we want to find our x-intercept and our y-intercept. So our y-intercept is when x equals 0. So f of 0 is negative 0 minus 1 squared plus 4. 0 minus 1 is negative 1. Negative 1 squared is 1. This becomes negative 1 plus 4, which is equal to 3. So we have a point 0, 3. We're going to plot that point here. I want to draw in here, we have an axis of symmetry. Remember, this axis of symmetry is the vertical line that goes through the vertex. So our vertex was 1, 4, so this is our line, x equals 1. Okay? So because we can take use of this axis of symmetry, and we can take advantage of this axis of symmetry, and we know that this point here, 3, 0 is a point on our parabola. So the axis of symmetry really means that, like, if we put a mirror there, we would get the other half of the graph. So we want to reflect this through. So we can go equal distance. We just draw a line vertically across there. We want our y value to be 3, and it's going to be equidistant from this axis of symmetry. So that gives us another point. This point is our intercept that we found. It's our 0, 3 point. Okay. The other thing that we can do is we want to find our x-intercept. So that's when f of x is equal to 0. So negative x minus 1 squared plus 4. We're going to set this equal to 0. So I'm going to add the x plus 1 squared to both sides. We get x, or minus 1 squared, is equal to 4. Okay? So we want to take the square roots of both sides. So we're going to end up with two possibilities, because whenever we take the square root, it's always plus or minus. So we get x minus 1 is equal to the positive square root, which is 2, or x minus 1 is equal to the negative square root, is negative 2. Okay, so we add 1 to both sides, plus 1, we get x equals 3, and here plus 1, we get x equals negative 1. So we have intercepts here. We have this point here and this point here. And as you'll see, those are equidistant to our axis of symmetry line. That's symmetrical about that line. So this is the point 3, 0. And this is the point negative 1, 0. And that kind of gives us enough of a rough idea of how to draw this graph. And I did a horrible job on that. Let's see. See if I can do better. Okay, so we have this parabola. And one more thing about this is because these are we'll be asked what the domain and the range are for these graphs. And whenever we have a minimum or a maximum, that's going to be a cutoff for our range. Our domain for any of these, it's a form of a polynomial, so our domain is always going to be negative infinity to infinity. But our range is going to be different. And in this one, the highest value is 4. So our range is going to be negative infinity to 4. And we have something at 4. So this can be a square bracket. Okay. So I think that's it. We identified that it was opening downward. We found the vertex. We found the axis of symmetry. We found some other points on this graph, and we were able to plot and graph that. The domain is always going to be negative infinity to infinity, and our range is always going to be determined by where our max or our min is. In this case, it's a max, so we're going from negative infinity to 4. So let's take another look at another example. And this is graphing it from the format of g of x is equal to ax squared plus bx plus c. Again, a is going to determine whether this opens upward or downward. If it's greater than 0, it will open upward. If it's less than 0, it will open downward. Our vertex in this format, there's a couple of ways that you can derive this. There's in the textbook, there is completing the square method of deriving this once you get to calculus. The way I remember this for the longest time was just doing the calculus of it. But the bottom line is our vertex is negative b over 2a. So that's the equation for our vertex. That's the x value of our vertex. And to get the y value of our vertex, we're just going to plug that into our equation. Okay. The axis of symmetry, again, is the vertical line that goes through our vertex. So it's x equals the x coordinate of our vertex. So let's take a look at this example. We have x squared plus 4x minus 1. So the first thing that I always want to do is I want to say, okay, my a is 1. So this is opening upwards. So we have a parabola that looks like this. And just in my head, that really helps. Okay, so our vertex is negative b over 2a. Well, b is equal to 4, so this is negative 4 over 2 times a is 1. So this is negative 4 divided by 2. This is negative 2. So negative 2 is the x coordinate of our vertex, but we have to plug negative 2 back into our equation to get the y coordinate. So we want to do f of negative 2. Negative 2. So this is going to be negative 2 squared plus 4 times negative 2 minus 1. So negative 2 squared is 4 minus 8 minus 1. So this is equal to negative 5. So our vertex now is at negative 2, negative 5. I'm going to go ahead and plot that. And I apologize, my graph went. I should have gone a bigger graph. But right at the edge here, negative 2, negative 5. Okay? The next thing we want to do is we want to find out our y-intercept. So we have f of 0 is equal to 0 squared plus 4 times 0 minus 1. So this is just negative 1. So we have our point of 0, negative 1, and I'm going to plot that. Okay, so now here is really where our axis of symmetry can come in. And again, our axis of symmetry is the vertical line that goes through our vertex. So this line actually is going to be x equals negative 2. But now that we have that, we can go back and we can reflect. We can say, okay, this point was here at negative 1, 0. We have one that's equal and opposite on the other side. So we went 2 to get there. We can go plot 1 here. So it just gives you another point, and you can check that. You can plug negative 4 in and make sure that you get negative 1, or get negative 1 back out, which you will. Okay, but we can do it real quick just using the axis of symmetry. Okay, and then we want to find our x-intercepts, and we're just going to use our quadratic formula. We're going to say negative b plus or minus the square root of b squared minus 4ac divided by 2a. That's going to give us the x coordinates of our intercepts. And when we do this, we end up with negative 4 plus and minus 2 square roots of 5 divided by 2. And this is equal to negative 4. Oh, sorry. This is negative 2 plus or minus the square root of 5. And then this is approximately 0.24 for the positive and negative 4.24 for the negative. So, wait, did I write that down right? Yeah. So we're about here, and we're about here. So those are our x-intercepts. And then we can draw a smooth curve here. Like this. Okay. Again, here our domain is going to be all real numbers. So this is going to be negative infinity to infinity. And our range, our lowest y value is negative 5. So our range, we're going to start at negative 5, and then it continues on upward to infinity. Okay. So regardless of what format it's in, how we'll go about it will be a little bit differently, but we're going to find the vertex, we're going to find the axis of symmetry, find our x-intercepts and our y-intercepts. and then we're able to plot the graph. You can always put in additional numbers to get more points if it makes you more comfortable, but that's how we go about graphing a quadratic function. There will be another video with some of the applications. So if you have questions on the application stuff, please go ahead and take a look at that other video.